Hello, my name is Matt Panunto, and I'm the geospatial ecologist for BLM Utah's West Desert District, and I'm based out of Salt Lake City. Um, I've also been a GISS for incident management for about the last 4 to 5 years. Anywho, today I'm going to be giving a demo on how to use my feature layer download tool. Like Andrew kind of touched on, I designed this tool to provide a simple way of downloading the data from Andrew's services. And though it was designed primarily with those services in mind, it can actually be used to download data from any published feature layer that you have access to. So that's why it's not called the US Forest Service National Base Map tool, because it kind of has a wider application than just those services. So if we want to proceed with this, we need to actually download the PanunTools toolbox, because that's where the tool is housed within. And that can be downloaded from my GitHub page, as Andrew covered. So there's a couple ways to get there. First, I'm showing the Wildfire Response GIS S3 community here, the user group. There's two recent forum posts here, the 2022 Fire Season GISS information post by Skip. And there's a link in there that'll take you to my GitHub page. And there's also a recent post by myself where I describe some of the updates I've made for the 2022 season. You can grab a link in there. Or you can just simply go to Google and type in GitHub and do a search for PanunTools. And it's publicly available, so it should pop up in that list. So this is the PanunTools GitHub page, and this will show you all the tools that are contained within this toolbox. There's a couple of different tool sets, but the one we're going to be looking at today is within the data download tool set and the feature layer download tool. This tool, like Andrew said, is not to be confused with the base data acquisition tool. It's a completely separate tool, and it does totally different things. So that's what we're going to look at today. But if you want to get this toolbox, at the very bottom of this page, there's a link here to download this repository. So we want to go ahead and click that. And it should initiate the download. Just give it a second. All right, so now we're going to extract this to, I created a kind of dummy incident directory. Our incident is going to be called 2022 _ feature layer download demo. Here's the standard incident directory, and we're going to just drop this right into the tools folder. Just going to drag it right over. All right. Oh, computer's hanging up a little bit. Just give it a second. Okay, so now we've got the toolbox and all of the accompanying files that you need to run the various tools of the toolbox, including the feature layer download tool. So we're going to open up ArcGIS Pro, and we're going to navigate to that incident directory. We're going to go inside the tools folder, and we're going to see that it's in there. There's a toolbox, PanunTools. So these are the tool sets that are contained within this toolbox. And again, we're in the data download tool set today, the feature layer download tool. Again, not to be confused with the base data acquisition tool. So I'm going to open up this tool, and I'm just going to kind of walk through all these parameters and kind of describe what they are and how you should perceive these things. So the first parameter is to connect to the feature services using ArcGIS Pro's Active Portal. This is a question, yes or no. So if the user wants to download data from services that are hosted within organizations that use more robust authentication methods, that's kind of what this parameter was primarily designed for. So, for example, the BLM uses SAML accounts which are tied to our Active Directories. There isn't a username or password for us to enter. BLM users, we just need to log into our computers using our PIV cards. And once we've done that, we basically have automatic access to the BLM organization after that. So if I wanted to download data from the BLM org, I can sign into the BLM portal from within ArcGIS Pro. So right now I'm signed into the NIFSI portal, but I could switch to my BLM portal right here. And then all I would have to do is set this parameter to yes, because it would be using my active portal that ArcGIS Pro is currently using. So even though I'm going to be tapping into the NIFSI org today, which uses a username and password, I'm actually going to go ahead and just set this parameter to yes. That way I don't have to share my password with everybody watching this video. And one last thing about logging into the NIFC org, if you want to be able to snag the data from Andrew's services, your portal URL has to be www.arcgis.com. It can't be nifc.maps.arcgis.com. For some reason, if you use nifc.maps.arcgis.com, the tool won't be able to connect to Andrew's services. And I think it has something to do with the fact that they were published outside of the NIFC org and are just shared to the NIFC org. And I guess this more kind of general portal URL gives you wider access. Not entirely sure about that, but for whatever reason, this is the only one that works. So I'm going to go ahead and hit yes. You can see up here that that is the portal URL that I'm currently connected to within ArcGIS Pro. And the next step is to create or specify the path to the area of interest polygon shapefile. So that is just a single polygon shapefile. So I'm actually going to create one right now. I'm going to call this AOI UTM-12 because I'm in Utah. And I'm just going to throw this into a new map. Like I said, I'm in Salt Lake, so that's what we're going to focus on today. And I'm just going to grab kind of the Salt Lake Valley. There we go. That's my area of interest. I want to download all of his services and pull data in for just this box, basically. All right, so we'll go back to the tool. Yes, and I'm just going to drag the AOI shapefile right into the parameter, and then I'll give you the full path to the feature class. The next parameter is specify AOI subdivision size in square miles. So let me bring up this little figure here. So when I first built this tool, it had difficulty downloading data for very large areas of interest. In this figure, you can see that the AOI is the entire state of Utah for the figure. The problem is some of the data sets are very high density, such as like local roads, NHD flow lines, PLSS, and a few others. And for some of these data sets, I would hit a selection or a query limit, and the tool would fail to download the data. So to work around this issue, this parameter is used to subdivide your area of interest into smaller pieces. The tool will then download the higher density data individually for each of the subdivided pieces and eventually merge it all together at the end to create a single data set. A parameter value of 5,000 square miles is the default, just because that's what worked well for me in testing, but feel free to modify this value as needed to see kind of what works for you and what you're downloading. So that's that parameter. I'm going to leave that at 5,000. The next one is specify output coordinate system. So the tool will pull all the data down and project it to your specified coordinate system if it isn't already in it. Specify output directory. So I'm just going to create one here. And drop that in. So that's the full path to the output directory. Specify path to feature layer download CSV. So this is a critical component of the tool, and this comes in the download package. So there's a file here, an accompanying file called feature layer download.csv. So let's open that up and take a look at it. So this file contains two columns of information. The first column is just a service name, and the second column is the item ID for that service. So this basically tells the tool what services it should try to download data for. So it will tap into each of these services individually, and it'll iterate through all the feature layers that are within the service and attempt to download the data for each of those feature layers. So this is fully customizable. If you only wanted to grab a certain number of these, you could just delete the ones you didn't want, save it, and then feed it to the tool, and that's all it would go out and get. Alternatively, you can also add services to this. So let's say I wanted to grab, I don't know, how about greater sage-grouse habitat, some greater sage-grouse habitat layer, and then you would just type in a name for the service and whatever the item ID is, you type that into, save it, and then it would go out and grab that as well. So we're gonna just swing that over into the parameter box. There you go, that's the full path to it. Okay, so the next two boxes are for acquiring elevation contour data from the USGS and wetlands data from the U.S. Fish and Wildlife Service. These are just questions. Do you want to do this, yes or no? We're going to set these to yes, but Andrew and his Forest Service colleagues were unable to publish nationwide services of elevation contours and wetlands data because these two data sets are extremely dense and it was just too much data to publish. So to work around this issue, I wrote some code that will manually pull these data sets together for the user's area of interest. These are the only two data sets that must be acquired manually in this way. All the others were successfully published as feature services. Let's see. So the next parameter is this checkbox for using the multiprocessor or not. So new for the 2022 season is a toggle that allows users to enable or disable the multiprocessor when running this tool. Previously, it was always enabled and you didn't have a choice, but I received a lot of feedback last season from folks who would encounter issues with the multiprocessor. Either it would hang or it would lock up, or for whatever reason, they just had to terminate ArcGIS Pro in order to kill the tool. I haven't been able to figure out why some folks have issues with the multiprocessor and other folks don't, but this toggle should at least allow everyone to use this tool successfully, although it will run slower without the multiprocessor, so just keep that in mind. So we're actually going to use it today. And when you check that box, another parameter drops into view, and it asks if an offline license check should be performed. And I highly recommend always setting this parameter to yes. So this will cause the tool to attempt to determine if your ArcGIS Pro license is currently offline. And if it's able to determine that it is offline, the tool will throw an error at you and recommend that you return it. To be very clear, I would not run this tool with an offline license. So a little bit of background as to why. I don't know exactly what causes this issue that I ran into, but when I was developing this tool, I somehow locked or corrupted 2 of my ArcGIS Pro licenses. I don't know. Again, I don't know what caused that, but it's only happened when my licenses are offline. I suspect that the issue has something to do with the tool logging in or switching the active portal while also having the multi-processing environment become stuck, and thus the user is going to have to manually terminate ArcGIS Pro as a result. Well, my guess is that in all that mess, there's a small chance for your offline license to become corrupted. And it's a huge pain in the neck to resolve this issue because Esri has to release the license on their end. And for me, it took over a week of back and forth communication with Esri to finally have them release mine. And you know, until that actually happens, your computer's basically a brick. You can't use ArcGIS Pro at all. You can't even switch to another license. And I can't imagine being on a fire assignment for several days dealing with that crippling issue. Thankfully, at the time, I had 3 licenses and 3 separate computers. So I was okay, but I don't know of anybody who carries 3 computers with them to a fire assignment. So again, I would not run this tool if your license is offline. Make sure you return it first. All right, so regarding the way that this tool actually uses the multiprocessor, if users have it enabled, the tool will actually go through multiple rounds of multiprocessor use, depending on what the user has requested in terms of did they ask for elevation contour data or wetlands data, so that'll change the number of rounds it needs. But for each of these rounds, several command prompt windows will appear on your screen, and just leave them be as they are your logical processors at work. It's similar to opening several instances of ArcGIS Pro simultaneously and running a tool across all of them. Don't exit them manually. They will close by themselves once they've all finished. Again, once they have all finished, so they will all remain on your screen, even if only one of them is still working. So I did want to show this real quick. So this is the Task Manager, and if you go to the Performance tab within Task Manager in the bottom right corner-ish, you can see how many cores your CPU has. So this particular machine that I'm on right now has 4 cores, and typically you have 2 logical processors per core, at least for the standard Intel CPUs that most of us government employees have. So I have 4 cores and 8 logical processors. So when I use the multiprocessor, it's going to pop up with 8 individual command prompt windows on my screen. Again, it's not a virus. It's nothing to be scared of. Just let them do their thing, and they will eventually disappear, hopefully, when they're finished. So I mentioned several rounds of multiprocessing, so let me just dig into that. So the first round is for the elevation contour data from the USGS. So when this begins, again, those multiple command prompt windows will appear on your screen, and those are your logical processors going to work. They will pull together all the contour data, and the windows will disappear once they're finished. The second round is for the wetlands data from the U.S. Fish and Wildlife Service. Just like the elevation contour data, multiple windows will appear on your screen again, and they will all go to work pulling this data together. Again, they will all disappear once they're finished. The third round is what I refer to as the primary feature layer processing. This is where the tool begins to actually establish connections to the feature services that were listed in that input CSV file that you can customize. So this round consists of feature layers with kind of lower density data, and because of that, they are downloaded for the entire area of interest all at once. Most of the services used in the U.S. Forest Service National Base Map will be processed during this round. However, there's one more round, the fourth and final round, and it's what I call the secondary feature layer processing round. And these are features with higher density data, such as local roads, NHD flow lines, PLSS, and a couple of others. This round uses the subdivided area of interest, which we covered previously. So if you're, for instance, thinking back to that figure, if your area of interest was the entire state of Utah and it was subdivided into roughly 30 pieces, the NHD flow line data set would be downloaded individually for each of those 30 pieces and eventually merged into a single feature class. Additionally, any data set that failed during the primary feature layer processing or round 3 will be attempted again here. Perhaps it failed because your AOI is very large and it hit a selection or query limit. If so, that failure will be recorded and the data set would then be dropped down into the fourth round where it will try again using the subdivided AOI to see if that can improve things. So that's pretty much all the multiprocessing in a nutshell. Okay, so I think that summarizes all of the inputs and also the multiprocessors. So let's move on to actually running the tool. Our inputs are all ready to go, so I'm just going to hit run. And if you ever run any of my tools, the first thing you probably want to do is immediately hit the View Details button, and this will kind of tell you what's going on. So we'll just wait for a second to watch this a little bit. So first it signs into the portal they have specified, and then it requests an API access token so that it can make connections to the feature services that you have listed there. Then it performs that offline license check if you tell it to. My area of interest is pretty small, so it did not subdivide it at all. I just have one whole area. If it was the state of Utah, this would be broken out into like 30 different object IDs. So the first thing it's doing is it's acquiring the elevation contour data, and you can see that it found that there's 28 geodatabases that it needs to download from the USGS. You can't see this right now, it's on my other monitor, but these are all the logical processors going to work. I'm just dragging them over here. If you remember my task manager, I had 4 cores and 8 logical processors, so I have 8 windows here. And they're all doing their thing. All 28 of those geodatabases are split across these 8 logical processors here, so they're only having to work 3 to 4 at a time. And we're just gonna let this run for just a little bit. So each of these workers is downloading the geodatabases, unzipping them, and then merging all the individual pieces of data together. And like this worker's finished already, this one's finished. These guys are still working, but they'll all finish eventually. And it's done. And it performs one final merge. So I'm actually going to cancel the tool right now. For the sake of time, I've actually already ran this tool for my area of interest, so we can skip ahead to taking a look at the outputs. Otherwise, we would just be sitting here for 20 to 30 minutes while it runs through the other rounds of multiprocessing. But hopefully, at least seeing the elevation contour process gives a decent idea of how this tool works. So you saw all the windows disappear, and after it would finish this final merge, it would move on to the wetlands data, and it would do pretty much the exact same thing. And then once that's finished, it would move on to tapping into all those individual feature services that you have listed in the CSV file. So I'm just going to put that away, and now we're going to go take a look at the output. So like I said, I ran this earlier, generated. Sorry, I just stuffed it in the base data folder under vector. So the final output of the tool is a geodatabase named feature layer download. It's pretty generic because it could be anything. But that consists of all the individual output feature classes that the tool created. So we can expand this and we can see all of the individual data sets that the tool pulled down. So you can actually just add any of these to your map. So let's just look at roads. And we can see that this is a pretty high density data set, but these are all the roads for my area of interest. You can see it includes everything inside that box. The problem is that the symbology is not what we need it to be to reproduce the US Forest Service National Base Map. So that's the next step. We need to apply the layer files that we have available to us to all these feature classes in order to create that base map. So what we're going to do is navigate back to the Panun Tools folder, and inside of this folder is a folder called US Forest Service National Base Map. And inside here are the fonts that Andrew was talking about previously. So you'll have to go inside this folder and install all those fonts if you want these symbologies to appear correctly within your software. But once you've done that, then you can use either of these two layer files that Andrew built and provides the symbology that he designed. So the first layer file here is the topo layer file, and this provides symbology for a topo style base map with pretty standard topographic features. And the second layer file is the SBS layer file, which provides symbology for a secondary base series style base map. This style is similar to that of like a Forest Service visitor map or a travel map. So one layer file might be more appropriate than the other, depending on the intended use of the map you're trying to build. But let's just take a look at the topo one. I'll add that to my map. And I'm actually going to dump all these other layers that were already in there. Okay. Next thing you need to do is resource one of the broken layers. They're all going to be broken when you first add this into your map. So I usually just like to add NHD point because it's just easy for me to find. So now navigate to where your output geodatabase is. Mine's C drive, workspace. There's our. So we could rename this to something more relevant. I could call this and then let's call NHD point. And then once you resource one, it should be able to find all the other feature classes located inside of the geodatabase. But it'll take a little bit here, just 30 seconds or so. Just be patient. You can see it's already filling in most of these. Okay, so once it's finished repairing all the broken layers, you may have a few that are still broken, like I have got one here, 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 and here, and there's probably a couple others. But the reason why those are still broken is it's most likely because that particular data set had no features inside of your area of interest, so there was nothing to download. So at this point, you can just remove those layers or you can just ignore them. But now with all the layers resourced to their corresponding feature classes, we now have ourselves the US Forest Service National Base Map for our area of interest, symbolized in the topo style. So I can zoom in here. You can see the layers start turning on. And yeah, it's got pretty standard topographic features, elevation contours, roads, rivers, PLSS, ownership, things like that. So that's pretty much it in a nutshell. If you wanted the SBS style, you would simply repeat that process of adding the layer file to your map and resourcing one of the layers, and it should pick up the rest that are in the geodatabase. I think that's it. Like I said, the only other thing would be that you have to make sure you install all these fonts. If you don't have all these fonts installed, then some of these little symbols here will look all goofy and have weird characters and things like that. So got to make sure you do that first before you want to use this product. And that concludes the demo of this tool. Thank you very much.